Okay, so we're gonna talk about the next thing. Next thing is called cross sections. Will.
Yeah.
Focus.
Cross section.
Okay. So we're gonna talk about volume based on certain geometric cross sections. Okay, so cross section, and we're gonna deal with volumes. Now, first thing that you're gonna think about is this. Sometimes they will have choices. The question will word it that's perpendicular to x-axis or perpendicular y-axis. You have to pay attention to that. So they will give you a choice A and B here. They will say in the question, they will say perpendicular to x-axis or perpendicular to y-axis. Second thing, you want to find the difference between curve. Usually means top minus bottom. And we're going to call it D. We're going to call it big D. Maturity of this class, right? This one is going to be dx. This is going to be dy. So if perpendicular to x, you're going to use dx. If perpendicular to y, you're going to use dy. Your question today on your homework sometimes is going to be perpendicular to y-axis. You had to solve everything in terms of y. 3. There are a few basic shape. So they will base the basic shape. There's a basic shape, basic geometric shape. And one of them is going to be a square. 2 is going to be equilateral triangle. The third thing is called semicircle. The fourth thing is going to be rectangle. And we're going to talk about those various type. It really depends on what the wording of it. Various. 5 is isosceles. Right. And it's going to be leg equal to the base. B is going to be hypotenuse is the base. And I'll give you the equation first. But first of all, let's truly understand to visualize the cross section. So what I want to do is we're going to show you a GeoGebra. You guys are more welcome to take out a computer and look up this. It's very, very cool. Like for me, I will take out a computer, or you can I can show you here. It's up to you.
Monsieur, I'm gonna need this because those words make no sense to me. I need to see it.
It doesn't.
So what do I type?
It's you're gonna search GeoGebra cross section AP calculus. GeoGebra cross section AP calculus.
Did you go back to your notes like really quickly?
Visualizing volumes by cross-section.
You want to take a picture?
Yeah.
You got it?
Yeah.
Okay. So what happened here is I'm gonna go to do this, and I don't know why it's not doing anything. I'm gonna try again. I don't know if the internet is up or down. Okay, so this is the shape. The red line's on the top, so I'm gonna use this perspective. So you see that left side of the graph is 2-dimensional, the right side is 3-dimensional graph. You see that red lines on the top on either one. Blue one is on the bottom. Now each one is, I'm going to build a one square. So you see that this is a square there.
Wait, how did you just do that?
I think you click square.
And then that shape is going to be square. But that square is based on the difference between two graphs. Remember, the difference of top minus bottom is that purple line on the left-hand side. Do you see that purple line on the left graph? Is the difference of top minus bottom. Now the difference is changing constantly. You know, closer to origin, the difference is very small. For example, look at this. It shrink. It go bigger. It shrink again, go back to smaller when it goes closer into each other. So basically, we want to use this geometric shape and we want to build it based on the difference of two curves. And we're going to decide that shape to be a square. So therefore, it's going to be like this.
Dude, I totally just drew the shape. Did I not? Jordan, did I not draw the shape? It's a square work.
Do you see this?
You got a little pointy signs. You just can't see it.
It looks like
Some people say it looks like opera house in Sydney, Australia. By the way, Sydney, Australia opera house, if you guys have ever been there, it's actually had a lot of mathematics in there. There was one math teacher actually did the whole documentary about how the math background of that building. It's actually very interesting. But it does look a little bit have like Sydney Opera House, but it's not the same because the way they form the shape is a little bit different. So this is just a square, right? So can I decide different shape? Can I say, let me go back and that just says, hey, let's do a equilateral triangle. So this, do you see that each shape is triangle?
Yeah. But like, it's gonna be the same shape in the end, right?
Yep, it's gonna be same shape, and it's gonna be. You can go all the way to here, and you can go here, and you see that it looks like.
something, but I can't.
Dinosaurs.
It looks like.
Bro, my computer
It looks like embryonical.
Is it?
Do you know what embryonical looks like?
I thought that's a university.
Yeah, it is, but
Is that where AJ wants to go?
It's a
No, I do not
dinosaur, so
go
like a dinosaur.
Wait, that's Connor going though.
Yeah.
You want to be a pilot, and this is semicircle. So this is semicircle here. Do you guys see this?
Yeah, it's a slug.
It's kind of like slug. Okay.
kinda. It's like they have like a building that has like kind of like the inside part of that. You know what I'm saying?
Oh, that's cool. This is embryo. Is that pretty?
Yeah, that's the main part of the campus.
Oh, that's nice.
I think
Daytona, yeah. Okay, so this shape. Now we're gonna go find value in this shape because we're basically just adding different slices of either square or equilateral triangle or triangle. We're adding all the slides using integrals. They are combined. Integral basically just combine all the things. So instead of finding area between the curve, you combine all the lines. You are combining all different kind of shape. We're not doing rotation this time. There's nothing to do with rotation. Just every cross section is exactly gonna be the same shape. Okay, so you can decide a shape to be. So those shape I usually decide to be squares or equilateral triangle or semicircle or rectangle. So if a square, it's gonna be like this. So square, it's gonna be the difference square. Why? Because D is the length of the difference between those two things. Now, if I square it, would I get a shape of square? Now, if I add it from A to B with infinite amount of pieces, that becomes a volume of that particular shape. And sometimes you're going to have to use dx. Sometimes you have to use dy. Depends on the question, because sometimes you're going to have dy. Because it's perpendicular to y-axis, you have to do it in terms of y. The next shape is equilateral triangle.
Oh, that's crazy.
It's gonna be square.
But it's gonna be integration of d squared dx between a, b, and then the only difference is a square root 3 over 4.
It's an equilateral triangle.
Actually, that's the formula to find equilateral triangle. Square root 3 over 4 times sine squared. So d squared dy. So you just remember the coefficients. This is the coefficient for equilateral triangle. I'm going to talk about why it's square root 3 over 4 in a second, but I don't have time. I just want to make sure I finish all of them before I go to equilateral triangle, or right now just memorize it.
What? Oh, it's gonna have to be like pi r squared or something.
Yeah, you're right. Semi-circle. This is actually a good one.
Is it 1/2
So-
pi r squared?
Yes, 1/2 pi r squared. But look at it. 1/2 pi r squared. That's where they start, right? So then you're gonna lead to integration of 1/2. It's pi over 2, so pi over 2 in the front. Now, in the between a to b of r squared, and then you're gonna say, wait, hold on a second. Let's go back. Look at the shape. Let's look at the shape here. If it's a circle, right? The problem if it's a circle, then that is not a radius. It's actually a diameter, because the diameter of a semicircle. So therefore, this one is gonna be, we're gonna use d from now on. So it's gonna be pi over 2, and we're gonna have a d over 2 squared. Does that make sense? Because the difference is a diameter. Divided by 2 becomes radius. And radius square, that's what it is. Now it's a to b, and now it's gonna be pi over 2 times a to b of d squared over 4. So can I change that to pi over 8?
Yeah.
And I still keep the d squared in here. So those are d. If you just want to memorize for semicircle, it's always pi over 8 in the front. Nothing different. Everything is the same. What's the next shape? Rectangle. So rectangle is a various because they can decide that rectangle with different dimension. So sometimes I use the dimension as like the base is twice of the height. And if I use this particular one, then you're gonna say, okay, well that's d is the base. Not d times 2. No. Pay attention to the questions. People are good at SAT. They read these things very carefully. Base is twice of the height.
Oh, that's 1/2 of d.
Yes, because the base is twice. So it's very easy to get confused because the way it's wording. So this one's gonna actually d over 2 and dx. Now, could be dx. This could be dx over pi over 8, a to b of d squared dy. It could be dy. So again, this one here, in this particular case, is d squared 1 over 2 between a to b dx. So this is a weird one that it happens. Now, so can it be twice of the height? Can it be 1/2 of the height? Can the height be 3? Can the height be 2? All those things can be various. That's why I say various. So it depends on the wording of AP exam. They're going to give it to you. You have to interpret it accordingly. I'm going to talk to the next one. It's isosceles.
So you're saying the formula is not always 1/2 b to a?
No, it's not always. This is various.
So the number in front varies.
Yes, the number it's in front is various. It could be 1/2, could be 1/4, could be 4th.
But it's always b to a. D squared.
Yeah, but you have to pay attention to this wording of this. It's twice the height. So if isosceles is lake, the base equal to lake, then that's actually easy, because if the lake is like this, that's just d. That's a d. So that's going to be 1/2 d squared. Now this one's for sure. It's 1/2 d squared. So 1/2 base times height. Or a to b 1/2 d squared dy. So either that or the other one depends on perpendicular to x-axis or y-axis. Now, if isosceles, the leg is equal to hypotenuse. That's kind of tricky because remember the ratio. The ratio is s square root 2s, right? Now, if we say the difference is equal to this, right? So difference is equal to square root 2 of s. Can I solve for s? So it'll be d over square root 2 equal to s. So then it's going to be d over square root 2 squared times half between a to b. So 1/2 base times height. So the base becomes d over square root 2. And that's 1/2 a to b. This one's d squared over 2. This becomes 1/4 between a to b of d squared dx. So if isosceles leg equal to hypotenuse, that makes it a little bit more difficult, but not so much more difficult, not something you can handle. You have to know your SAT materials. We're going to talk about the last part. Hold on a second. Let's go back talk about y is square root 3 over 4. Since we are on the ratio, we have enough time, then we're going to talk about y at the square root 3 over 4. Is that going to help you on SAT? I don't know, but it helps you understanding stuff. So if this is the s, this is the s, this is s, that means they are equilateral. If it's equilateral, also means they are equal angular. Equal angular means each angle is what? 60. Does that make sense? Okay, now in your geometry class, talk about this. It's called perpendicular bisector. Or perpendicular, this is angle bisector and perpendicular bisector at the same time. So this is a perpendicular bisector. Will, come back to me. Use only now again. 30 degrees.
Yeah.
So since they are segment bisector, this is the s over 2. Does that make sense? So s over 2. You say, okay, well, according to the ratio, 30 degrees, 60 degrees, this is SAT. This works like $50 an hour. I'm trying to teach you. Pay attention. If this is s over 2, now remember the ratio. The ratio is what? This is s, this is 2s, this is square root 3 times s. But the problem is s is not s in this case, it's actually half s, right? But, so this one becomes square root 3 over 2s. Does that make sense?
Wait.
So 1/2 base times height. Again, 1/2 base is going to be s. S is the base. Height is going to be square root 3 times 2 times s. So therefore, it's 1/2 times square root 3 over 2 times s squared. S is the d. So it'd be square root 3 over 4 s squared. Lead to square root 3 over 4 integration a to b of d squared dx. So there's actually a formula can find equilateral triangle, area of equilateral triangle without going to 1/2 base times height, because usually equilateral triangle does not give you height. But you can actually find that using 30, 60, 90. So every time I teach something, I also help you with the SAT technique. This is a SAT technique. Sheila probably know that every SAT has this questions, right? 30, 60, 90, and 45, 45, 90. And guess what? We just reviewed both. And which is, you can be like Anthony Teeter, you have daddy's money, can pay for it, the SAT training course, or you can get it here for free.
Yes. Okay, Mr. A.
But if you want to pay for the course, they just ask you to do problem. You could do that at home too.
You can do it for free.
You can do it for free. But you just have to have the right knowledge. What?
790 right here, sir.
Oh,
790.
790, that's weak.
Yeah, 10 off.
Yeah. Should get higher than that.
Yeah.
The SAT right now is almost way too easy.
It is.